Next problem up is number 12. Again, if it wasn't for that n, that would have been geometric. I would have saved myself a lot of time. So if I take the limit as n approaches infinity of the absolute value of negative 1 to the n over n plus 1, 5 to the n plus 1, times x to the n plus 1, divided or multiplied by the reciprocal, which is negative 1 to the n minus 1, and that will be n 5 to the n, x to the n. That would be the limit as n approaches infinity of, now we know that negative is going to disappear. You'll have a negative 1 to the negative 1 at the bottom, but the absolute value will take care of that. So the negative will go away, but it is x to the n times x to the 1 over n plus 1 times 5 to the n times 5 to the 1 times n 5 to the n over x to the n. So the negative disappeared because the absolute value will take care of that every time. Right? There's only a single negative. It's multiplied by all of those. So I'm left with the limit as n approaches infinity. X is independent of n, and 5 is independent of n. I'm looking at n over n plus 1, right? And if I divide, actually I could use L'Hopital just on this part. That would be 1 over 1. So this limit will equal the absolute value of x over 5. If I set that less to be than 1, right, and cross multiply, I will get absolute value of x to be less than 5. There's my r. And x is between negative 5 and 5. That's my interval, except again I have to test the endpoints. And let's see how that works. So to test the endpoints, I need to take x equal negative 5 and x equal 5 and see what happens. If I take x equal negative 5, I'm looking at the series n equal 1 to infinity, negative 1 to the n minus 1 over n times negative 5 to the n, oops, messed up, wrong place, times 5 to the n times negative 5 to the n. Right there, that's the only value that will change. And if I look at that closely, that's the series n equal 1 to infinity, negative 1 to the n minus 1, negative 1 to the n, times 5 to the n over n times 5 to the n. Well, those cancel out. And if I combine those, that's the series n equal 1 to infinity, negative 1 to the 2n minus 1 over n. This is positive, decreasing. The limit as n approaches infinity of 1 over n equals 0, therefore converge by alternating series test. So up till now, I know the radius is 5, and I know the interval negative 5 is a bracket. And if I take x to equal 5, I'm looking at the series n equal 1 to infinity, negative 1 to the n minus 1 times 5 to the n over n times 5 to the n. Those cancel out, and that's gonna be pretty much the series n equal 1 to infinity of both the same. Okay, well, let me test. That's positive, decreasing, and the limit as n approaches infinity of 1 over n equals 0, therefore converge by alternating series test. I have to test this part. If I add those, negative 1, that will be negative 1 to the 2n. If n equal, so 2n minus 1. If n equal 1, if n equal 1, that's a 1. If n equal 2, that's a 3. Oh, it's always odd. So it's always negative. My mistake. I gotta fix this part. So that is the series n equal 1 to infinity, negative 1 to the 2n minus 1 times 5 to the n over n 5 to the n. Those cancel out. So that's negative the series n equal 1 to infinity of 1 over n. My mistake, you guys. I got carried away. Well, this is p equal 1. therefore diverge. So take that back. I can't have that, but I can have this. So we're going to say negative 5 not included and 5 included. The next problem, well, the same deal. I'm going to take the limit as n approaches infinity. Actually, here I could apply the root test, can't I? Because I could think of that as nx to the n. That's not geometric because there's an n there. So that would be what? That would be the limit as n approaches infinity of nx, and that would be infinity. Well, if I'm trying to get this to be less than 1, how is that possible if it's always infinity? So here we say that's not possible. So the radius of convergence is 0, and the interval of convergence is 0, meaning what? Meaning the kill switch, let x equal, you can only control x. If you let x equal 0, guess what? That series will die out, but that's really not saying much. Let me move 14 up there. I don't know what's down there. And this problem, the same deal. If I take the limit as n approaches infinity of x, now be careful, a sub n plus 1, there we go, over n plus 1 multiplied by the reciprocal. That is the limit as n approaches infinity, x to the 2n, x to the 2, because that's 2n plus 2, over, and watch. Isn't this factorial bigger than that? So if I start reducing this, I'll get there. Those two cancel out. Those two cancel out. I'm left with the limit as n approaches infinity of x squared over n plus 1. Remember, as far as n is concerned, x is a constant, that's 0. Isn't that always less than 1? What does that mean? Therefore, this will converge for all x, for all values of x. So we say r is infinity, and the interval is negative infinity to positive infinity. And there it is. Okay, 20, same deal. Limit as n approaches infinities, a sub n plus 1, multiplied by the reciprocal. That is the limit as n approaches infinity, 2x minus 1 to the n, 2x minus 1 to the 1, 5 to the n, 5 to the 1, square root of n plus 1, 5 to the n, radical n, over 2x minus 1 to the n. Things cancel out. I am left with the limit as n approaches infinity of the absolute value. And let's see, the square root of, if I combine those and divide by the highest power term of the denominator, a nice trick that I picked up from horizontal asymptotes, that's 2x, oh, I forgot the 5. Right? If I set that to be less than 1, or 2x minus 1 is less than 5, there's my radius of convergence. Once I get this, that's my r. And the interval of convergence, well, if I take 2x minus 1 to be between 5 and negative 5, add 1 to both sides, x is between 3 and negative 2. I need now to test x equal negative 2. If I put a negative 2 right there, I'm looking at the series n equals 0 to n equal 1 to infinity. Negative 2 in there. Negative 2 times 2, that's negative 4 minus 1. That's negative 5 to the n over 5 to the n radical n. That is the series n equal 1 to infinity. Negative 1 to the n, 5 to the n over 5 to the n radical n. Those cancel out. This is positive, decreasing. The limit as n approaches infinity of 1 over radical n equals 0, therefore converge by alternating series test. So now I know that in the interval of convergence, negative 2 is included. And I go to x equal equal, what did we say, 3? If I put a 3 there, 6 minus 1 is 5. That is the series n equal 1 to infinity of 1 over n to the 1 half, p equal 1 half less than 1, therefore diverge. There's my interval, and my radius is a 5. Alright, one more problem to go. Let's think about this for a minute. So I think of those just like we did domain back in the days, ages ago. Suppose that this series converge when x equal 4, negative 4. Well, if they said negative 4, they included negative 4. That means this is centered at 0, right? So they must have tested negative 4 and 4. And then they said this series diverge for x equals 6. If you plug in 6, this diverge. And they must have tested negative 6 as well. So anything outside of that region is going to diverge for sure, right? Because 6 diverged. Anything above is going to be divergent. Well, let's see. Here, isn't this saying this is the series n equals 0 to infinity, c sub n times 1 to the n? That means x equal 1. Where is x equal 1? X equal 1 is right there. If negative 4 converge, that means anything in there will converge. B. Isn't x equal 8? Isn't 8 to the right? If 6 converged or diverge, automatically this is going to diverge. Actually, one thing I was going to mention, we're not sure whether this is, we don't know much about the negative. We know they tested the negative 6, but they only checked 6. So we don't know whether this converge or not, diverge or not. How about negative 3? If x is negative 3, isn't negative 3 right there? What did you say, converge? And I added a problem. How about if x equal 4? Where is 4? 4 is right there. We do not know. Alright? And there's the homework.